today, if we can, we're going to get the weak acids, weak base calculations done, and we will have a look and see can we get our titration curves, and then we look to see can we bring Dan back for the next part. So this was the 2011. We've done this one, correct? And it was this one. So calculate the pH of a 0.2 molar solution of a weak acid, the value of whose acid dissociation content is 6.3, and what would be the solution of a sulfuric acid solution that has the same pH. So all you were doing was 6.3 by 10 to the 5 by 0.2 in your square root and shoving it into your formula. So that should be okay.
Yeah.
Okay, so then we had a pH of 2.5 and it's asking us concentration of a sulfuric acid solution that has the same pH. So when you've got to use your inverse log here. So is that you say shift log, isn't it? Shift log negative 2.5, and that gives me 3.54, which is our hydrogen ion concentration. But you have to know that sulfuric acid has 2 hydrogen ions. So this is the equivalent of 2, and you need to turn that into a 1. So 1.77 by 10 to the minus 3. We all okay on that one? You need to talk to me.
Yeah.
Or nod heads.
Yeah.
Okay. Alrighty. So, can I flick off the screen? This is the 2017 question. And I am looking at, so it says pH values of 0.1 molar sulfuric, hydrochloric and methanoic acid respectively are these numbers. We might as well do the whole lot of it. In terms of hydrogen ions, account for the difference in the pH values of 0.1 molar HCl and 0.1 molar sulfuric. So you're using your hydrogen ions. And the pH values for your sulfuric is 0.7. For your hydrochloric, it is 1. And for your methanoic, it is 2.37. So why do you think there is a difference between 0.1 molar of hydrochloric and 0.1 molar of sulfuric? Why you're getting the different pH values?
They have different molar masses.
Nope. So remember now, pH is negative log to the base 10 of your hydrogen ion concentration. So what has to be different between the two of them? The concentration is the same.
The amount of hydrogen in it.
Yeah, so which one has more hydrogen?
Sulfuric.
Yeah, so you have to recognize that it's HCl versus H2SO4. You have to recognize that these guys are both strong acids. So they're both going to fully dissociate, but the sulfuric will give you twice the amount of protons as hydrochloric. So then if we look down to the next one, what's the reason why you're getting, again, a pH of 1 and a pH of 2.37? What do you know or can you infer about methanoic acid? What does it sound like? It sounds like something else we've done recently.
Methane.
Say it again, Karen.
I said methane.
No. So what family does methanoic acid come from?
Carboxylic acid.
Carboxylic acid. Thank you, Keith. We've done ethanoic acid. Is ethanoic acid a weak acid or a strong acid?
Weak.
It is weak. So methanoic acid is going to follow the same vein in that it is going to be weak. So this is our methanoic acid, and it is this H is your acidic hydrogen. It's only going to slightly dissociate in water. So this fully dissociates, your HCl fully dissociates into H plus and Cl minus. This will only slightly dissociate. So the vast majority of your methanoic acid will be present as this, as opposed to HCOO minus plus H plus, only a real small percentage. So this will contribute all of its H pluses to the pH of 1, whereas this is only a weak acid, slightly dissociates. It's going to have a higher pH. It's not going to be as low. Does that make sense? So now we get to the maths part. So it says use the pH value given for 0.1 molar methanoic acid, and now we have to calculate the Ka value. So we have the concentration, we have a pH, which is the 2.37, and now we're going to have to play with our formula a little bit to work it out. So I'm just going to write what we have. So we have the pH and we have our concentration. We also have the equation for a weak acid, which is pH negative log base 10 square root of Ka by Ma. So we need to now move things from the left or from the right to the left such that all we're going to be left with is this. So how do I get rid of the log? What do I have to do to both sides? So I want to change what's on my right hand side so that Ka is all on its lonesome. So what do I have to do?
Multiply by it.
So to get rid of the log, I would inverse log function, and that will help it to cancel out. So it will be, you have shift log negative pH is equal to square root of Ka by Ma. How do...
Isn't log just 1 over log?
It essentially, yes. I'm just going to do it out in the way that we've been talking about when we inverse our pH. I'm just going to use that same language if that's okay. So you will never more than likely have to show how you get it. You just have to use the kind of the final part, but I'm going to show you in terms of the maths. So how do I get rid of the square root on the right hand side?
Square it.
So you have to square both sides. So we go inverse log minus pH. I am now going to square that, is going to be equal to Ka by Ma. How do I get rid of the Ma on both sides?
Divide by Ma.
Divide by Ma, so log minus pH squared over Ma is equal to Ka. So you have your little grey box, and that is the key formula. So you can either derive it from this in real time, or you can just learn this and then you apply it. So if we then put in what we have, so it is inverse log pH, so inverse log negative 2.37 to be squared over 0.1. When you do all of that, it should come out as 1.8 by 10 to the minus 4.
Yes, why is the pH negative?
Because remember when we do our inverse, so it's this negative here, we have to, this negative up here, Sam, that we have to include when we go to this second line here. It's not just going to disappear.
Yeah.
So if you have to, if you want to find hydrogen ion concentration, that this is the piece of maths that you would do.
Okay, thanks, miss.
Okay. So this answers part 3 of that 2017 question. And then it says you have to have the pH of a 0.05 molar solution of methanoic acid. So this is your dissociation constant. It's the Ka, and you now have a new concentration. So what do you think you do? So we now have a Ka of 1.8 by 10 to the minus 4, I have a concentration of methanoic acid of 0.05 m. So how do I find pH of a weak acid?
Put it into the formula.
What's the formula?
They're like pH minus log 10 square root all on.
Good woman. Okay, so to find the pH, I need to shove it into the minus log to the base 10 square root of Ka by Ma. So minus log to the base 10, 1.8 by 10 to the minus 4 by 0.05. And when I do that, I will get 2.52. So there are 2 weak acid questions, 2016 10A. Okay, gotta find questions for you. Insert new slide. Okay, so you have room for the 2016 10A part 2, and you are also going to have changing my share. So there is a 2012 10B, there is a 2015 9D part I, and there is also 2016 10A part 2. So I'm going to leave you to those for 10 minutes or so. You can ask questions if you need to. Need to find the 2015 question for myself. Somebody's very loud calculator buttons.
Miss,
Yeah.
for 2015, is the pH equal to 3.3?
The pH is equal to 3.3. How did you get that, Cam? So help everyone out. How did you get it, Cam? Am I on mute? Yeah.
Because it's asking for the initial concentration. So is that like, I just thought it was the concentration from the start.
Yeah, it's from the data in the table. It's the zero data.
Yeah.
Well done. Okay, how are we doing? Happy to go through? I think I can see everybody's heads except Chloe. So we're on the noddy stage, or we're still waiting? So thumbs up or thumbs down? Thumbs up, thumbs up. Lucy is a thumbs down. Juno's a thumbs up, thumbs up, thumbs up. Ruth, how are you? Roisin's a thumbs up. Okay, so we'll give the ladies a couple of more minutes.
Miss, do you have the answer for 2016?
So 2016 answer is 0.56.
Okay, thanks.
Is that a smiley face or a sad face?
The smiley face, yeah.
Yay. Alright, start putting up the 2012. So it is very straightforward. You have concentration, you have a Ka value, so you are literally just plugging it into the formula, and when you do that you get 2.85. For the 2015 higher level 9D, when you read your question, it's giving you a Ka value of 1.8 by 10 to the minus 5. It is asking you for an initial concentration, so that's the MA is a question mark, and it means you have to have a pH somewhere. So the pH came from the table, and the initial pH on the table was equal to 3.3. So then you are rearranging your formula slightly. So last time it was inverse log negative pH to be squared over MA when we wanted to find Ka. So now it must be this over Ka, which will be equal to MA. So then I plug it into my calculator, and I would always do it as it's written. Didn't want to do that. I would always do it as it's written. So I literally would make the fraction. Sometimes when you put in the inverse log negative pH and you try do a bracket afterwards, it doesn't like it. So I personally put in the brackets first and then I fill the brackets, if that makes sense, on my calculator. And I'm putting that over 1.8 by 10 to the minus 5, and when I do that, it is coming out at the 0.014. Be happy?
Thanks. Do you ever divide H's? Like if there's more H's in the formula, do you ever change, or is it always the same?
So this, because it's a weak acid and because it's really only the carboxylics that are going to be important, there's only one proton. It's only you're always going to have the Ka value, and that gives you your level of dissociation. It's not like when we do strong acids on strong bases and there's definitely 2 H pluses or there's definitely one. Does that make sense, Lucy?
Yeah.
Okay, because I don't know now, is it my Wi-Fi or your Wi-Fi? So then the last question was the 2016. So 2016. So your pH was equal to 2. Your concentration was equal to 0.01. And your Ka was the thing you were trying to find. So again, we are using the inverse log minus pH to be squared, and has to be over MA to find Ka, and I just then plug everything in. So inverse log negative 2 to be squared over 0.01, which when I do that gives me 0.56 m. Happiness is? Thank you, Roisin, for the good affirmative. Okay, can I flick to their next side? So I'm just going to pause you for 1 second because I think I have to come out to come in.
Miss,
Yep.
why are you using 0.01 there? Because in the question it says 1.8 times 10 to the minus 4.
The 1.8 by 10 to the minus 4 is the Ka value. It's the dissociation constant. I don't have the question in front of me. But if you read the question, it should have said your pH was 2.
Yeah, but Miss, why do you put the 0.01 underneath the...
Yeah.
It should be 1.8, shouldn't it? Because you bring the...
Apologies, and I've just disregarded everything. So, hold on, we resume share, we start again. So we had a pH is equal to 2, apologies. We had... MA was equal to, so okay, I'm asking you this because I can't see the question. I'm just doing it off what I've written already. So you had a pH 2 and you have a Ka value, correct? Is that what it is?
Yeah.
Okay, so I apologize because I'm just doing it off what I've written like last year. Okay, so we are saying our formula is inverse log negative pH squared. It is going to be over Ka to give me Ma. I am then going inverse log negative 2 to be squared over 1.8 by 10 to the minus 4, and that will be 0.56, so I apologize. Everyone is happier? Yes?
Yep.
Okay, I'm gonna come out of that, discard that. We've done, so we are going to, we've already done our strong acids, strong bases, so we're just going to flip ahead. It's page 150 on mine, and we're going to look at weak bases. So you already, because you come preloaded, because we've done the weak acids, this should make some sense to you. So just like our weak acids, they're only slightly dissociated in water. They will always have a dissociation constant, except this time it's going to be called Kb because it's to do with bases. And then you just have to adjust your equation to suit that. So when we did bases, how did I figure out a strong base? What were the steps that I had to do a strong base? Do you remember?
Find the POH first and take away from 14.
Yeah, so you have to find your POH first, which is your negative log to the base 10 of your OH minus concentration. And then you had to go 14 minus POH to get your pH value. So we're going to do similar here, except we now are dealing in POHs. So what do you think the formula for a weak base is going to be? To get the POH of a weak base, what do you think it's going to be? So it's related to the weak acid.
Would it be like the answer minus 14 instead of...
So that's going to be our second step. So there will be a 14 minus your POH. But what is the POH equation? So it's a weak base. So it's going to be like the weak acid, but there'll be a slight change.
Minus log 10.
Yeah, of what? So minus the log 10. What else am I going to have?
of root KB and the concentration.
Yeah, so
Times concentration.
concentration. So instead of calling it Ma now, which is concentration of acid, they call it concentration of base. And then your pH will be equal to 14, take away your POH. So we still have two steps. And the only difference now really is we'll now have, they'll call it KB in a question.
What does
Yeah.
the P stand for in POH?
Say it again.
What does a P stand for?
So
in
the
POH?
P stands for, it's called potential. So it's potential of hydrogen and pH, how many H pluses are there. And for POH, it just stands for potential of hydroxide ions. So how many hydroxide ions are there? So you have a question underneath. So is it okay to change my share?
Yeah.
Yeah, Izzy, you're okay? Okay, so this is the question. There's not that many examples of it, of weak bases being asked. So it is the rarest of them all. You happy to look at it?
Yep.
So
Yeah.
it's you have your MB, you have your KB, so it literally is you're just plugging it into your formula. So square root of 1.8 by 10 to the minus 5 multiplied by 0.0001, and when you do that it turns out as 4.37. So your pH value then is going to be 14 take away 4.37 is equal to 9.63, and two significant figures in your question, 9.6. You also have, so it says underneath, calculations for weak bases have only been asked once since 2003. So you're looking for 2013 higher level 11B. Do I have it written in here? Yeah. So 2013 higher level 11B. Okay, are we happy to try it? Yes?
Yeah.
Alrighty, so you had to have your weigh in, which was 7, had to be divided by 35 to turn it into moles. So 0.2 m, so moles per litre. And then it was a matter of filling in your information. So negative log to the base 10, it was your square root of Ka, which was 1.8 by 10 to the 5. Multiplied now by the 0.2, which gave you 2.72, and then it was 14 take away 2.72 gives you 11.28, and because of, can't see the question, so I would put that as 11.3. Okay, we're all happy? Can there be nodding of heads? Okay, so